Welcome back, everyone. We're diving into the world of binary stars today,
Binary stars, yeah.
using a really cool physics resource.
Okay.
It's got simulations
Right.
to help kind of visualize how these star systems work.
Oh, that's cool.
It focuses on a specific problem
Okay.
with a gravitational force between two stars,
Mm-hmm.
but there's a twist.
What's it?
There's a missing value in the equation,
Oh,
and you get to figure it out.
sounds fun.
Yeah, it's like a cosmic detective story.
That's a good way to put it. I really like how this resource
Yeah,
uses visuals to make it, like, less abstract.
right.
Instead of just equations on paper,
Mm-hmm.
you can see how it actually plays out,
Yeah,
like in a simulated star system.
definitely. So before we jump into the problem itself,
Sure.
can we just back up a bit?
Huh?
For someone who's maybe not an astrophysicist,
Yeah.
what exactly a binary star system?
Simply put,
Okay.
a binary star system is two stars
Mm-hmm.
that are locked in a gravitational dance, orbiting around their common center of mass.
Interesting.
You can think of it like
Oh,
two weights on a seesaw.
Okay.
Trying to balance them.
Yeah.
That point where the seesaw balances perfectly,
Right.
that's the center of mass.
Gotcha. That makes sense. So they're both swirling around that central point.
Exactly.
But why are binary stars so important?
Good question.
I mean, are they more than just a cool phenomenon?
Oh, definitely.
Okay.
They're actually very common in the universe.
Yeah.
And they help us understand a lot of things,
Like what?
like stellar evolution,
Okay.
formation of planets,
Wow.
even the nature of gravity itself.
Really?
It's like having this cosmic laboratory
Mm-hmm.
where we can watch these massive objects interact.
Fascinating. Okay, so what about this problem in the resource?
Sure.
What kind of binary system are we dealing with here?
So this one focuses on a system with two stars,
Mm-hmm.
one with a mass of m,
Okay.
and the other twice as massive at 2m.
Got it.
They're separated by a distance of 3x,
3x, okay.
and they're rotating in perfect circles
Interesting.
around that common center of mass.
Right.
But here's the mystery.
Okay, the history.
The gravitational force between them
Mm-hmm.
is described by an equation,
Okay.
but there's a missing value
Oh.
represented by the variable k.
A missing piece of the puzzle. So
Totally.
to solve it,
Yeah,
we need to understand the equation itself.
exact.
So remind me, what is the equation for gravitational force?
It's a classic from physics class.
Yeah.
F equals g times m1 times m2,
Mm.
all divided by r squared.
Right.
Yeah.
That one,
Yeah.
it's amazing how that one equation can describe,
Yeah,
the
Literally.
force that holds galaxies together.
really is.
What's so special about the gravitational constant G?
G is a fundamental constant.
Okay.
It's the same everywhere in the universe,
Oh, wow.
which is pretty remarkable.
It is.
It's like a universal language for how objects with mass attract each other.
So it never changes.
Nope, it's constant.
That's incredible. And you'll notice that the force gets weaker as the distance are.
And increases, yeah,
The further apart they are,
Yeah.
weaker the pull.
exactly.
Makes sense. But how do we apply this equation
Okay,
to
so
our binary star puzzle?
we take the information we know
Okay.
about our stars,
Mm-hmm.
their masses, m and 2m,
Right.
and their distance, 3x,
Mm-hmm.
and plug those values into the equation.
Substituting those in. So we're substituting m and 2m for m1 and m2.
That's right.
And 3x for r. What happens next?
From there, we simplify the equation,
Why?
squaring 3x, which gives us 9x squared.
Okay.
Then we rearrange things to isolate k.
So we're using algebra
Yeah.
to solve for the missing piece.
Exactly.
I'm on the edge of my seat. What's the value of k?
After all that,
Yeah.
we find that k equals 2/9,
2/9.
which is approximately 0.22.
Okay, so it's not just a random number. It
Wow.
tells us something. It says about this binary system.
Yeah, like it's stability.
Interesting. If k was different, the stars might drift apart.
Or even collide,
Wow. So this seemingly simple calculation
right?
has big implications.
It does.
But this resource doesn't just stop at equations, right?
No, it doesn't.
You mentioned visualizations.
Yes.
What does that look like?
So they've included an interactive simulation
Okay.
where you can actually see the stars orbiting.
Hold on. So we can actually watch these stars move
You got it.
based on what we just did.
That's right.
That's taking this to a whole new level.
It is. It's pretty cool.
Wow. We've gone from equations on a page
Mm-hmm.
to watching stars dance around each other.
I know, right?
It's incredible how a physics problem
Uh-huh.
can open up a whole new world
It really is.
of understanding about binary stars.
Definitely. Yeah. It really shows you the concepts in action.
Yeah, and it's like you have a mini universe right at your fingertips.
Exactly. And what's really cool is this equation, this concept of gravitational force.
Okay.
It's not just limited to binary stars.
Really? So you're saying it works for any two objects?
Pretty much. It describes the attraction between any two things with mass.
Wow, that's amazing. So we could even use it
Yeah.
to calculate the force between the Earth and the Moon.
Absolutely.
I mean,
They're not stars, but they definitely pull on each other.
exactly. The equation is universal like that.
So if we wanted to calculate that force,
Mm-hmm.
we'd need their masses,
Yep.
the distance between them,
Right.
and that constant g.
That's it. It's the same process as the binary star problem.
Gather the info, plug it in, and bam.
You got it? Physics explains things big and small.
It's amazing how it all connects. But why is it so important to understand this force?
Okay, so
Especially with binary stars. What does it tell us?
gravitational force is like the architect of the universe. It shapes how galaxies and stars form.
Wow.
And with binary stars specifically,
Okay.
understanding it helps us figure out
The masses of the stars, their orbital periods, even how far away they are.
it's like a cosmic ruler and scale all in one.
Exactly. And don't forget about stellar evolution.
Right. Binary stars can interact in crazy ways.
They do, yeah. Like one pulling material from the other,
Oh, wow.
or even merging together.
Creating huge explosions.
Exactly. We can learn so much from those interactions.
Like what?
About the life cycle of stars,
Okay.
how heavier elements are created,
Mm-hmm.
and even how black holes might form.
It's like they're these,
They're like cosmic laboratories.
yeah, letting us see some of the most dramatic things in the universe.
It really is incredible.
So it's much more than just two stars orbiting each other.
Definitely. It's a whole complex dance unfolding.
And speaking of visualizing that dance,
Yeah.
that interactive simulation we mentioned,
Right.
it's like turning the equations into a 3D movie.
It is. And it's a great way to see how they move.
I can't wait to check it out. But
Yeah.
before we do that,
Okay.
I want to step back for a second.
We started with a simple physics problem.
Right.
And ended up talking about black holes.
I know, it's amazing how it all connects.
It really is. It just shows how interconnected everything is.
Yeah, it really shows that sometimes even the most complex ideas can be understood by starting with something simple.
Like just asking the right question.
Right. In this case, it was, what is K?
Exactly. It's
That was-
all about that curiosity.
And seeing where it leads you.
And this journey, I mean,
Yeah.
we've come pretty far.
We have, from gravitational force
Mm.
to stellar evolution and black holes.
It's pretty amazing.
But before we wrap up,
Sure.
we've talked about applying this equation to binary stars
Right.
and the Earth and Moon.
Uh-huh.
But what about other objects?
What do you mean?
Like, could we use it for planets in our solar system?
Whoa, yeah.
Or even stars in a distant galaxy?
It's a fascinating thought.
It is.
But the answer is yes.
Really?
Absolutely. Those laws of physics,
Yeah.
they're universal.
So the same principles that govern the motion of stars in a binary system
Right.
also apply to the largest structures in the cosmos.
Exactly. Think about it.
I-
The force that makes an apple fall from a tree
Right.
is the same force that holds planets in orbit around the sun.
Wow. So it's all connected.
It really is.
It's incredible to think that we can use these equations
I know, right?
as tiny beings on this planet
Mm-hmm.
to understand the forces shaping the whole universe.
It is pretty humbling,
It is humbling.
but also empowering in a way.
It is. It makes you feel like you can unravel these big mysteries.
And we are just getting started.
Right. There's so much more to learn
Definitely.
about binary stars and the forces that drive them.
It never ends.
Well, I'm so glad we took this deep dive into binary stars today.
Me too.
It's been fascinating.
Yeah.
And I can't wait to explore that interactive simulation.
It's really cool. You'll love it.
Awesome. I encourage everyone listening to do the same.
Yeah, definitely.
Oh,
It's a great way to see it all firsthand.
And remember to keep looking up at those stars.
Always.
Keep asking questions and never stop exploring.
That's what it's all about.
That's what it's all about.
Exactly.
Well, on that note, we'll wrap up this deep dive.
Sounds good.
Thanks for joining us.
Thanks for having me.
And until next time,
See ya.
happy stargazing, everyone.